Hello class. In this lecture I will talk about hypothesis testing for two population means. So when I say two, we are comparing two different populations. We will be using Zstat in this lecture. So as you know, from one population mean problems, Zstat is used when the sample size is greater than or equal to 30 and your population standard deviation sigma is known. So that is what we will be discussing in this lecture. So firstly, when we are comparing two populations, if you see, if I have a population 1, so this is suppose city 1. So and I am comparing the weights of people in these cities. So the average weight of city 1, suppose I represent by mu1, and then I have population 2, and this is suppose city 2, the weight of people in city 2 is mu2. As you know, these mu1 and mu2 obtaining is difficult, right? However, three different things that can happen when you are comparing weights of two different cities. One is the weight of people, the average weight of people in city 1 is equal to city 2. So that is mu1 is equal to mu2. So since both the city 1 and city 2 population weight is exactly equal to it is a two-tail problem. So this expression can also be written as mu1 minus mu2 is equal to 0. So two same numbers, if you subtract them, it will give you 0. So that is one instance that can happen. The other instance that can happen is your mu1 is less than or equal to mu2. So what that means is city 1's weight is less than or equal to city 2. So this again can be written as mu1 minus mu2 less than or equal to 0. So that is again, if you see this is we are doing one side of a normal distribution. So this will be, we are analyzing on one side of a normal distribution, so it will be a one-tail problem. So we are saying that population 1, city 1's people's weight is less than city 2. So the third instance that can happen is mu1 greater than or equal to mu2. That means city 1 people's weight is greater than city 2's people weight. So this can also be written as mu1 minus mu2 greater than or equal to 0. Again, this is one tail problem. as we are analyzing one side of a normal distribution curve. So based on these three, we can develop a hypothesis. So let me write the first test of the first step of a hypothesis testing. So the first step is to define hypothesis. So three different hypotheses can happen. So the first one is your null hypothesis, where you can say mu1 is equal to mu2. So this can also be written as, or H null mu1 minus mu2 is equal to 0. So the alternative for this would be mu1 not equal to mu2, and then alternative, or it can be written as mu1 minus mu2 not equal to 0. So this will be a two-tail because we are saying it's exactly equal. So we assume that we are trying to say that both the city 1 and city 2's population are equal. That's why we can disprove that if it is less than or more than one city's weight is less than or more than the other city, then we can disprove our null hypothesis. So this is two-tail. The other situation that can happen in our hypothesis is one-tail problem. So H null mu1, the city 1's weight is less than or equal to mu2, or we can write this as H null mu1 minus mu2 less than or equal to 0. So the alternative would be mu1 greater than mu2, or H alternative would be mu1 minus mu2 greater than 0. So the third situation that can happen in a hypothesis testing is H null mu1 is greater than or equal to mu2. That is, city 1's weight is greater than city 2's weight, or you can write this as H null mu1 minus mu2 greater than or equal to 0. So alternative would be mu1 less than mu2, or H null mu1 minus mu2 less than 0. So these are the three situations that can happen in hypothesis testing for comparing two population means. Again, it depends on whether you are using mu1, mu2. If your city 2 is mu1, then the whole situation might change. So let's do the second step of our hypothesis testing, is to compare test statistic with critical value. So the test statistic, we are doing Z. So again, when do we, so I will just write the formula for Z first. Z stat. So the formula would be x1 bar minus x2 bar minus mu1 minus mu2 divided by square root of sigma 1 square by n1 plus sigma 2 square by n2. So the importance of this formula, let me discuss how this formula came. So as you know, when we compare two different populations, we don't know it's difficult to get mu values, mu1 and mu2, because if we are doing for a whole city, it's difficult to get the population parameters. So what do? We take a small sample, so from city 1, and the sample size is n1, and then your sample mean is x1 bar, and then in this case we assume that your sigma 1, which is population standard deviation, is known. So this is what we are assuming. Again, if we have city 2, we take a small sample, so the sample size would be n2 and the mean would be x2 bar, and we assume here also that sigma 2 is known. Sigma 2 is known. So as you know, Zstat can be used in one sample. This was the criteria. In two sample, the criteria would be same, but now instead of n being greater than 30, we are saying n1 is greater than or equal to 30 and n2 is greater than or equal to 30, and your sigma 1 and sigma 2 both are known. Then we use Zstat. So that is the criteria to use Zstat. So I will write the criteria here to use Zstat for comparing two population means. N1 greater than or equal to 30, N2 greater than or equal to 30. Sigma 1 is known, sigma 2 is known. So that is the criteria we are using, and then this is called the standard error in the formula. So now if we wanted to compare this with critical value, you know, for two tail the critical value is, if it is a Z-stat, Z alpha over 2. For one tail it is Z alpha, and then finally we will be making conclusions. So these are the steps you will follow for Z-stat. And then we can make we can again use a confidence interval also to make interpretations or comparisons of two different populations. So the confidence interval formula, confidence interval for mu1 minus mu2, that is for comparison of two populations, would be x1 bar minus x2 bar minus plus Z alpha over 2, and then sigma 1 square by n1 plus sigma 2 square by n2. So if you see here in this case, this is critical value, this is standard error, and then this whole thing is our margin of error. So we can use the same confidence interval also to get to compare two different populations. So I will try to take a problem and solve the problem. This is I will use a two-tail problem to solve it. Okay, so this is the question. An analyst wants to know whether there is a difference in the weight of people of Killeen and Harker Heights. The mean weight of 64 people sampled in Killeen is 164 pounds, and the mean weight of 50 people sampled in Harker Heights is 166 pounds. Assume that the population variance is known for Killeen and Harker Heights. The population variance for Killeen is 9 and the population variance for Harker Heights is 16. Is there enough evidence to claim that there is difference in the weight of the people of Killeen and Harker Heights at 95% confidence interval? So here we are comparing two different cities, that is Killeen and Harker Heights. They are saying whether there is a difference in the weight of, so they are kind of wanted to see whether there is a difference in the weight. So this is alternative and this is null. So we are looking at whether mu1, so Killeen I will represent by mu1 the population mean, and for Harker Heights I will represent, so this is Killeen, and then for Harker Heights I will represent by mu2. So I'm saying mu1 there is a difference, right? So that is what they are saying, there is a difference in the weight. That is what we wanted to evaluate. So when mu1 is not equal to mu2, that means they are different. So this is alternative is what is given, and then our null hypothesis will be both will be equal. So this is our hypothesis. So this is the first step, which is to define your hypothesis. So for the second step we need the data. So this all is given. Let me write given. What all is given? The weight of 64 people sampled in Killeen. So N1 is, so this is Killeen data I'm writing here. So N1 is 164 and the mean weight x1 bar is 164, and then the mean weight of Harker Heights, let me write Harker Heights, N2 sampled people are 50 in Harker Heights and the mean is 166, and the population variance is known. So sigma 1 square is known, for both sigma 2 square is also known. So the for Killeen it is 9 and for Harker Heights it's 16, and then we wanted to do 95% confidence interval. So we have this data. Now the next step is of a hypothesis testing. The next step of a hypothesis testing is to, let me see, is to compare test statistic with critical value. So the test statistic, the formula, now we are using Z because N1 is 64, which is greater than 30. Your N2 is 50, which is greater than 30. Sigma 1, this is known. Population variance is known. This is also known. So that's the reason why we are using Zstat. So Z is equal to x1 bar minus x2 bar minus mu1 minus mu2 divided by square root of sigma 1 square by n1 plus sigma 2 square by n2. So this one, x1 bar is 164 minus x2 bar is 166, and then mu1 minus mu2. So if you see, so mu1 minus mu2, so if you see this, mu1 is equal to mu2. The other way of saying this is mu1 minus mu2 is equal to 0. So that means the other way of saying this is mu1 minus mu2 not equal to 0. So this the equal to 0, mu1 minus mu2. So this value comes from hypothesis, null hypothesis. So this comes from H null. So that is 0 divided by square root of sigma 1 square is 9 over n1. N1 is 64 plus sigma 2 square is 16 over n2 is 50. So if you kind of calculate this, the z value, the top would be, the numerator will be -2 and the denominator would be 0.678694. So this is going to give you -2.94. So you got a test statistic value. So the next step is to calculate critical value. So to do a critical value, we will look at whether it is a one-tail problem or a two-tail problem, because we say mu1 is equal to mu2, both are equal. If mu1 is less than mu2 or if mu1 is greater than mu2, that means this hypothesis becomes false. So we can disprove null hypothesis on both sides of a normal distribution curve. So that means our critical value will be z alpha over 2. So they gave us 95% confidence interval. So alpha would be 1 minus 0.95, which is equivalent to 0.05. Alpha over 2 would be 0.05 over 2, that is 0.025. So let me show you how this looks in a normal distribution curve. So if I have a normal distribution curve like this represents mu1 minus mu2 is equal to 0 point. So this is 0, mu1 minus mu2. So anything to the left would be mu1 minus mu2 less than 0. That means mu1 is less than mu2. That means Killian's weight will be less than Harker height. Anything to the right, mu1 minus mu2 is greater than 0. So mu1 greater than mu2. That means Killian's height would be greater than Harker heights. So at this time we are looking for 95% confidence interval. So this from here to here, this is 0.95. So when we say 95% confidence interval, this is the area in which mu1 is equal to mu2. So this will be mu1 is equal to mu2. So this will be a region where you do not reject H null. And then we have this region in which mu1 would be less than mu2, as we discussed here. So that means you will reject H null, that means mu1 will not be equal to mu2. Again, in this region you will reject H null. Mu1 will not be equal to mu2. So in fact mu1 will be greater than mu2 in this region. So that is how you are reading this, the entire stuff. Now we wanted to get our z values at this point. So this is negative z alpha over 2, and then this would be positive z alpha over 2. So we know this will be 0.025, which is alpha over 2, and then this will be also 0.025, which is alpha over 2, and then we go and check in z table. So z table is going to give you this left side of the curve. So you are looking for z 0.025. So here the probability is 0.025. What is this value? So I will go to z table and look for that value. So I go to our canvas and go to modules and go to our calculation aids in module 0, and then statistical tables, and look for so I will be looking for z 0.025. So I will do enable editing. I have a Poisson table, so I will go to z table, and then I will be looking for a probability of 0.025. So 0.025, so that is this one, so that is negative 1.96. So I'm looking at negative 1.96. So this will be negative 1.96. So I will go here and write, so this value z alpha over 2 here will be negative 1.96. so this one here will be plus z alpha over 2, which will be positive 1.96. so this is negative. So now the next step is to look at this and compare. So our z value is negative 2.94. so this is negative 1.96. so the z value negative 2.94 will lie to the left somewhere here. It will be negative 2.94. so it falls under rejection region, reject H null. So that means our conclusion is to reject your H null. So that's how you'll be solving. So one of the things is because it fell on the left side of the normal distribution and within the rejection region, your mu1 is less than mu2. The other way is Killeen has less weight compared to Harker Heights. So we are rejecting this so this is false, this statement is false. So that means inherently this statement is true. So there is sufficient evidence to show that there is difference in the weight of people of Killeen and Harker Heights. So we can kind of say the conclusion would be there is sufficient evidence to claim that the weight of people of Killeen is different from Harker Heights. So usually you can use confidence interval also. So a confidence interval, you have lower value and higher value. So if lower value is negative and the higher value is a positive number, here you have 0 in between it, so your null hypothesis mu1 minus mu2 will be equal to 0. If both are negative, so that means mu1 minus mu2, so both are negative means mu1 minus mu2 is less than 0. So in this case you are saying mu1 is less than mu2. If both are positive, then you are kind of saying mu1 minus mu2 is greater than 0. That means mu1 is greater than mu2. So I will discuss this concept when we solve it through our calculation aids. So let's do the same problem using our calculation aids. Again, I will note down all the values which were given in the problem. So I will go here and I'm going to copy down the entire hypothesis to all the values given here. So I will go, so our hypothesis is our null hypothesis is mu1 is equal to mu2, or alternative is mu1 minus mu2, mu1 is not equal to mu2. And then for Killeen, our data set says n1 is equal to 64, x1 bar is 164, sigma 1 square is 9, and then for Harker Heights n2 is equal to 50, x2 bar is equal to 166, sigma 2 square is 16, 95% confidence interval. So now I will go to our calculation aids and try to solve this problem. Okay, I will go to our canvas, go to modules, module 0, and then go to calculation aids, download chapter 11 calculation aids, and then to enable editing. And then we have 4 different sheets: known variance, unknown variance, mean, paired, and proportion. Which one to use? So since we have in our problem the variances are known, the population variances are known, so these are known, we will use known variance sheet. So again you are using Zstat because your variances are known and your sample size 64 for Killeen is greater than 30, and for Harker Heights N2 is greater than 30. You will be using Zstat, that is, you will be using known variance sheet in your calculation aids. So now we go here, we have the gray area is where you will key in your values. So the first value is sample mean. So let me see what is the sample 1 mean for sample 1. Sample mean for sample 1 is, I'll use a different color. So sample 1 sample mean is 164. So this is 164, and then I have sample standard deviation. I need I go here, sample standard deviation is, so the variance is given as 9, so what would be the standard deviation? So if sigma 1 square is 9, what is sigma 1? Square root of 9, which is 3. So 3 will be our standard deviation. So I will type in 3, and then our sample size for sample 1, our sample size is given as 64, so I will type 64 here. And then I'm going to go to sample 2 data, which is Harker Heights. So I will go to sample 2. So your sample mean is given as 166. So this is 166, and then this is sample standard deviation, population standard deviation. So population standard deviation is given as, so the variance is given as 16, so sigma 2 square is 16, so sigma 2 is square root of 16, which is 4. So you will key in 4, and then sample size here, sample size is 50, So I will go and do 50 here. And then they are asking us to calculate alpha. So they gave us 95% confidence interval, so alpha would be 1 minus 0.95, that is equivalent to 0.05. So our alpha is 0.05, so I will go and type in 0.05 and hit enter. So your test statistic value is negative 2.94, and now which case to use? This is case 1, mu1 minus mu2 is greater than, mu1 minus mu2 less than, for alternative. So this is case 3 for alternative, mu1 minus mu2 not equal to. So let's go and look for our alternative hypothesis. So if you see our alternative hypothesis, if you look at it, this can be written as mu1 minus mu2 not equal to 0, and again this can be written as mu1 minus mu2 equal to 0, but they asked us to look for alternative, which is mu1 minus mu2 not equal to. So I'm going to go and look for mu1 minus mu2 not equal to. So H alternative mu1 minus mu2 not. So I'm going to use this criteria. So the critical value is 1.959 and you reject the null hypothesis. So that is you are using case 3 in this because it's not equal to, it's a two-tail problem. So again we have different values here. This one critical value 1.96, this is for confidence interval, and then the standard error is 0.67869, that is what we got. And then our confidence interval is negative 3.33 to negative 0.669. So again I will write that here. So the confidence interval, if you see, I discussed here, was negative 3.33 is our lower bound, and negative, I think it's 0.669. So let me go and cross check. Yeah, so if you see here, so when you collected your sample, the worst gap that happened was negative 3.33, and the best gap that happened was negative 0.669 between Killeen and Harker Heights population. That means mu1 is less than mu2. That means Killeen has less, because these numbers are negative. Killeen has less weight compared to Harker Heights. And it makes sense because when you subtract smaller number minus the larger number, you should get a negative number. So this represents for mu1 minus mu2 together. So this concludes my lecture on hypothesis testing for population, for two population means using Zstat. Thank you.